All right, so one of the reasons that I like to call this showers of fire is we're talking about meteor showers. And probably the one that we think about or hear about the most is this one in August. And it's called the Perseid Meteor Shower. We'll find out why here as we jump into the program. When we hear this term meteor shower, it might conjure up an image of a constant rain of shooting stars. But is this really what's going on? Actually, to get to the bottom of what meteor showers are and where they come from, let's talk about what a meteor even is. It's hard to tell sometimes from still images in books, magazines, or online. For example, pictures of comets and meteors look very similar, but there are some very distinct differences. In fact, if you look closely, can you tell? The comet over here looks kind of nebulous, especially the tail. It's kind of fuzzy and seems to fan outward, whereas the meteor is a very distinct streak. Comets look faint and fuzzy because they are still way out in space, orbiting around the sun. Think of it as a dirty iceberg, millions of miles away. And so if you happen to see one in the sky, it will not seem to be moving at all. Remember, think of them as still orbiting around the sun like a planet. In the case of meteors, on the other hand, these are small bits of ice and rock or metal that burn up as they enter the Earth's atmosphere. They are the tiny leftovers from the formation of the solar system, but they can also come from the asteroid belt or from comets. Meteors can enter the atmosphere at speeds between 15 and 45 miles per second. Yeah, that's right. I said per second. Not too hard to see why they will burn up in the atmosphere, right? They usually disintegrate high up, somewhere between 20 and 50 miles above the surface. That's why the streak may appear for only a split second to maybe just several seconds at the most. It might be hard to imagine, but most of these are no larger than the head of a pin. I know, kind of hard to imagine that, isn't it? Well, it's because most of what you're seeing is not the solid particle at all, but the air that's glowing, or we say ionized, around the entering meteor. Okay, so far we've mentioned comets, asteroids, and meteors. And while they are all related, leftovers from the formation of the planets, let's be clear about how they differ. Comets are balls of ice and dust, maybe only a few miles across, that sublimate into gas and dust as they near the sun. Asteroids are larger bodies, anywhere between 30 feet and 300 miles across. Most orbit in the asteroid belt between Mars and Jupiter, but some are in other orbits that can cross the Earth's orbit. Meteoroids are similar to asteroids, only smaller, between flecks of dust and 30 feet across. This is what we call them when they're still out in space. When a meteoroid enters our atmosphere and becomes a bright streak in the sky, that's when we call it a meteor. Oh, and one more. You've probably heard of a meteorite. Well, that's what you get if the meteoroid is large enough to survive the plunge through the Earth's atmosphere and reach the ground. That's when you can pick up a piece of it. That's when we call it a meteorite. And some of them you've probably seen in exhibits. They can be pretty large. A lot of these tend to come from the asteroids, leftovers in the asteroid belt. So when it comes to different uses of the word meteor, just remember they're all the same thing, just in different situations. So the meteoroid out in space, the meteor burning through the atmosphere, the meteorite when it's on the ground. And I think we've also cleared up that a meteor is not really a shooting star or falling star. That's the popular name. It's not really a star that sprang from its place and vanished. It's just those little tiny solid particles burning up in the air. On any one given night, if you go out away from city lights and there's no bright moon in the sky, you might notice 4 to 5 meteors coming out of the sky each hour. That's a meteor streak about every 12 to 15 minutes, if you can take in most of the sky. They can also appear to come from random locations among the stars. But then we have the phenomenon called a meteor shower. Simply put, it's an increase in the average number of meteors coming out of the sky per hour over and above the average rate. It doesn't necessarily have to be a rain of meteors, it's just an increase over the norm. At specific times of year, the average hourly rate can increase from 15 to as many as 100 meteors in an hour. And for meteor showers, they always seem to emanate from one location among the stars. It's rare to see more than, say, 100 meteors per hour, but the great Leonid meteor storm of 1833 really freaked people out because they saw hundreds of thousands of meteors in just one night. This really literally did feel like a rain shower. And in those days, you could probably imagine some people were wondering if the world was coming to an end. But this event, more than any other, initiated the first serious study of meteor showers. By the 1860s, calculations revealed that meteor showers occurred when we crossed the orbit of a comet. So what is it about comets that causes this? It turns out that a comet's orbit is not an imaginary path in space like the planets. As it comes closer to the sun, it sheds particles of ice and dust that are left behind in its orbit. As a result, it's better to think of a comet's orbit as a continuous river of ice and dust moving in the same direction as the comet. Every time the Earth crosses one of these dust rivers, it can stop millions of orbiting particles, and an alert observer might see the few hundred that streak down over his location. This is the phenomenon we call a meteor shower. Since they're all coming from the same direction in space, we see them emanate from a single location in the stars. This is called the radiant point. The fact that they seem to radiate outward from a central point is an optical illusion created when parallel trajectories approaching you seem to diverge outward. It's the same experience you get when looking down parallel lines that converge in the distance. Same effect. Meteor showers are named for which constellation contains the radiant point. In November, for example, the Leonid meteor shower seems to originate out of Leo the Lion. There are at least 8 good, reliable meteor showers throughout the year, and really dozens or maybe even 100 minor ones. But some of these are not these, but some of the smaller showers are so weak that you can barely notice the difference from any normal night of sporadic meteors. But these here are among the more impressive showers throughout the year. They can vary in terms of how long they might be active. It could be 3 days or 3 weeks that you'll see them, depending on how spread out the orbiting particles have become. So why is it that we seem to mostly only hear about the Perseid meteor shower in mid-August? Well, it's not because it has the highest hourly count of meteors, although it can be a lot. As many as 120 meteors in an hour have been recorded. There's actually several reasons. One is that the Perseids exhibit more fireballs than any other meteor shower. A fireball is a meteor brighter than the planet Venus and can be really quite spectacular, as they seem to light up your surroundings for a split second. Another factor is that August in the northern hemisphere, of course, is a warm time of year, perfect for camping, making the big regional star parties popular around the peak of the Perseids, or just camping in general. Many can appear yellow in color with glowing vapor trails, something else that's somewhat special to the Perseids. Other colors have been recorded, but the vapor trails seem to be more common with the Perseids. Some of those trails might be so bright as to leave a faint smoke trail for several seconds after the meteors burn through. Here's a few time exposures that show an example of a persistent vapor trail. Isn't that cool? Here's another one. It's really rare, but I have heard reports of people that could see that faint smoke trail or vapor trail for like 30 to 60 seconds afterward. That's incredibly unusual, but it has been known to happen. Another phenomenon to watch for, especially during the Perseids, are called bolites. These are fireballs that break up into smaller bits or can even explode. Clearly, these meteoroids are larger in size, maybe the size of your fist or more, baseball or a basketball, and these fall deeper into the atmosphere. The peak of the Perseid shower generally hits the August 11th, 12th, 13th time frame, but we encounter the comet debris beginning 3 weeks before the maximum. This is one of those that has a nice slow ramp up. In fact, I go out in the middle of the night sometimes to let my German Shepherds out, and even from my backyard in Essexville, I'll just look up at the sky for a few minutes. And I think it was a week ago, I already saw a Perseid. And I knew that it was a Perseid because it was emanating from the northeast, where the constellation of Perseus is rising. In fact, that brings us up to the next question. When are you supposed to look? When is the best time to look for the Perseids? Well, the radiant point needs to be above the horizon and preferably high in the sky to maximize the number of meteors you can see. The radiant in Perseus, you can see here, is below the W of Cassiopeia. Some people know that one because it's a nice bright group of stars. And it can get to a respectable altitude by, say, 11 p.m. or so. But the best show of Perseids is usually after midnight. Yes, the radiant is higher in the sky in the post-midnight hours, but it's also the time when our part of the Earth is facing into the direction of its orbit. That means we're plowing head on into the stream of particles, allowing us to see more. Think of it this way. It's kind of like if you're out driving on a summer night, you'll see a lot more bugs on the front of your windshield than on the back. You're moving forward into the stream. The map also indicated this thing called a double cluster nearby, near the radiant. And you might just barely see it right here. It's 2 tiny little clusters of stars. Looks spectacular in binoculars, but you can just barely see them to the naked eye in a dark, moonless night. But you know, knowing the exact location of the radiant is not really that important, and not even the constellations for that matter. All you really need is to know the general location that the meteors are going to seem to be streaking out of. So if you know that the northeast is where the radiant point is, just get your lawn chair and face northeast, lean back, take in as much of the sky as you possibly can, because the Perseids may not necessarily start in the northeast. They can appear anywhere in the sky. It's just that if you trace their direction backward to their point of origin, it'll seem to be the northeast. So don't worry about finding constellations or knowing where the double cluster is. Those are just some added pluses if you want to do a little added stargazing. But the northeast is where they'll seem to be emanating, and it'll be more numerous after midnight. Best thing to do also is to get out into an open field where you can get as much of the sky as you can with minimal light pollution. And to keep the sky as dark as possible, you also want little or no moon in the sky. Bright moonlight can wash out all but the brighter meteors. Well, for the Perseids, we're really fortunate this year because there will be a crescent moon, and it sets before midnight during the peak nights. Remember, though, the moon will not be at the same phase on the same date each year. The lunar month does not line up exactly with the calendar month, so check out the phase of the moon before you plan to go meteor watching. For example, I thought I would look ahead to next year for the Perseid peak next August 2022, and I think you can see, unfortunately, there's going to be a big bright full moon to interfere next year. So good to look ahead. Also be sure and get dark adapted. That means at least 20 minutes in the dark with no white lights. If you're close to town, find a place you can at least shield yourself from street lights, car headlights, and porch lights. If you're doing some stargazing at the same time and you want to read your star charts, then use a red filtered flashlight so it doesn't interfere with your night vision. Bring warm clothes, even in the summertime. It can get cool at night. And if you're going to be leaning in that lawn chair, bring a blanket or some warm drinks, just so you can be as comfortable as you can, taking in as much of the sky as you can. Remember, the first rule of stargazing is to be comfortable. And remember to use your peripheral vision. You might see a meteor kind of start out of the corner of your eye, so you can quickly move to try and catch it. One of the favorite things that you'll hear at night, actually to me one of the funniest things you'll hear if you're ever out with others watching for meteors, if somebody is watching in a different direction, it's funny because you'll hear everybody, a lot of people go, "Oh," when they see one, and then they'll always be followed by one, "Oh, I missed it," afterward. So try to keep your eyes out, and it's always kind of fun. You can have a good time. And again, you might notice that there's some different colors in some of these meteors. I mentioned yellow, but other colors have been reported in the Perseid meteors. The color depends on two things: their composition and the speed with which they enter the atmosphere. While the Perseids are known for being green, purple, pink, orange, and even white, the December Geminid shower, for example, only show tones of azure, turquoise, and emerald. The Perseids' colors have been traced to calcium, sodium, magnesium, silicon, and even iron. Those are the colors that would come from the vaporizing of the meteoroid itself. And the Perseids are actually quite fast. They enter the atmosphere at something like 37 miles per second. So they're going to be pretty quick. Remember to watch for those fireballs. The meteor's brighter than Venus. They will seem to get brighter and almost bluer sometimes. You can see them change shape and brightness as they enter. And then also, don't forget to keep an eye out for bolides, those fireballs that might actually disintegrate and break up. Those can be really cool. And count yourself fortunate if you happen to see one breaking apart like that, because they are very rare. One of the other good meteor showers of the year is the Geminids in mid-December, and they've been known to create fireballs and bolides as well. So what if you miss the peak on the 11th, 12th, or 13th, or the weather is bad? The shower doesn't just suddenly stop after a couple of nights. It gradually tapers off, especially in the case of the Perseids, because the river of dust is so spread out that we're passing through. They should actually be worth watching through about August 17th. But as you can see, they're already active now. Here we are at this point. It should, if you go out, you might already be able to see 10 or 15 per hour on a good dark night. Okay, to help you out a little bit, I did collect a couple of references here for you. Some good references about when there are some good meteor showers, even some minor ones, if you care to look and see if there's any other active meteor showers going on. And then at the bottom, the American Meteor Society has a good article about this year's Perseid display. Okay. So if there's time and if anyone has some questions, I'm more than happy to try to answer some.
Let's see. If we want to, since we have some extra time, if anybody wanted to unmute and turn their camera on and ask a question, or if you'd like to drop one in the chat box, if you have anything that you'd like to ask Mike, we can take some time to do that.
Sure.
Okay, let's see.
I hope that helps you get primed a little bit.
Oh, here, maybe I can can I unmute?
Looks like someone was trying to unmute.
I think so, and there. George,
Okay.
I think we got you.
Yeah, it looks like it finally got unmuted. Do we ever get a situation where a meteoroid is coming perpendicular and therefore we get a bright spot? There's been some nights when I look up and I see what appears to be just a flash as opposed to a streak.
Yeah, that is possible. If they happen to be coming in almost directly into our line of sight, you probably would not see as much of a streak, but it would be possible to just see the flash. That's a really good point. In fact, it reminds me to talk about something else. Remember when I was mentioning that after midnight is good because the Earth is starting to turn in to the debris field? Well, before midnight, they're kind of grazing almost perpendicular to the ground, or parallel to the ground. And so you can get what are called earth grazers. So if you do look around 11 p.m., midnight or so, sometimes if you see a Perseid, you might get a nice long streak across the sky. And so it's good to start looking at about 11.
Thank you.
That's a good question. Thank you.
Thank you.
Yeah, 2 nights ago there was a fireball
Oh yeah, good.
about 12 o'clock.
Nice. And the nice thing about fireballs is even if there is a little bit of a moon or a little bit of lights, you'll still see it. Here's another little tidbit that might surprise you all. I've had it asked, because during a meteor shower, you've got so many more meteors coming out of the sky. Wouldn't the chances of a meteorite increase? A chance of some of those reaching the ground? And actually, almost the opposite is true. Remember, most of these particles are really tiny, leftovers from comets, which means they're mostly ice or little bits of dust. And so most of them would never be big enough to make it all the way to the ground. The meteorites tend to come from the asteroid belt because they're more rock and metal. So there's your little bit of meteor trivia.
Would anybody else like to? You can ask a question in the chat box, or you're welcome to unmute and turn your camera on if you'd like, or just to unmute. We were talking earlier about the dark sky parks here in Michigan, and I thought those were really interesting. What's the closest dark sky park that we have to us, Mike, again?
I believe the closest is Port Crescent, and we like to do some star parties for them. In fact, we will be doing a Perseid Meteor Shower star party on Friday, August 13th, up at Port Crescent. They have, remember, the little separate area for the Dark Sky Preserve. And so we'll be there along with the Sunset Astronomical Society, and we'll even have telescopes to look at a few other objects as well. But if anyone wants to join us, if it's cloudy that night, we will try again on Saturday the 14th.
Okay, great. And are those, is that on the Delta, is that on the Planetarium website? The
It
details
is.
about
It'll be on the Delta Planetarium website, and also we'll have it posted in our Facebook page as well.
Okay, great. That sounds like fun. And if it moves to Saturday, that'll get posted, updated too.
Yeah, probably the best place to check would be on our social media.
Okay, great.
Instagram. Yeah, we'll be mentioning in there if we have to go to the backup.
Yeah, sounds great. Let's see here. Oh, from Rhonda. Learned a lot as always. You have the best programs. Thank you so much. Thank you, Mike. That was very, very enjoyable.
Thank you. We love doing it.
Anybody else have any questions they'd like to ask? Questions, comments? No. Okay, well, we'll say thank you to Mike. We appreciate you very much joining us tonight. That was a wonderful program. So yes, please do check out the Delta College Planetarium. You can check out the website. As Mike said, they will be reopening next week. That's exciting. And if you're interested in the star parties at Port Crescent, check out their website and social media pages for more details. Thank you.
Thank you all. And hopefully we'll get to see you at the planetarium or another one of our live streams.
Absolutely. Thank you, Mike.
Thank you.
And thank you, everyone. Have a great evening.
Sandra, wait, don't stop. I have a question on Facebook. I got to cut and paste it. Just a moment, please.
Sure.
Oh, okay.
Just came in.
Okay. Okay. Allie would like to know a good spot to try to view the showers from.
You know, if you want to get a little bit further out of town, but you don't want to drive a long ways, even Bay City State Park gets a little bit darker. I like sometimes to go up to Nyanquin Point on Kitchen Road, you know, there on the bay, and that's not very far. It's like another 20 minutes from town. And it is really, what's nice is that it is really dark there, and you also get a really nice, big, open sky, good horizons.
Oh, what park was that again, Mike?
Nyan. I don't know if I'm pronouncing that exactly right, but if you go, it's along the shore of Saginaw Bay, further north from Bay City State Park. And so you go, if you were going up 13, look for Kitchen Road. You'll see a sign there for it. Take a right and just follow it all the way to the end. There's even a nice observation tower there.
Yeah, I might have to check that out myself.
And there's also the state park up at Pinconning. They have.
Yeah, that'd be a great choice too.
There's more trees there, but
yeah,
Nyanquin Point is really a good open area.
Yeah.
You can also, that's also relatively close, is there's a park. I'm trying to remember the name of the park that's just to the east of Essexville. There is there's a boat ramp and everything right there.
Oh, is it Jones Road?
Yeah, I think it's the one on Jones Road.
Maybe Jones Road Park. Yeah. Okay, so that'd be a good. Yeah, that sounds.
Yeah. I'll post it on our Facebook page. Sorry, the name of the park is escaping me right now.
Okay. Yeah. The pressure. Okay. Thank you. Does anybody have any more questions? No. Okay, well, we will bid you good night once more, Mike, and thank you again very much for the presentation tonight. Thank you,
Yeah,
and
thanks
everybody
for
have a
having
great evening.
It's a real pleasure.
Thank you. Thank you.
All right, take care, everybody.
Thank you.